Hi, it's Mr. Guffick here, and I thought I'd look at another example of the differentiation optimization kind of exam question that is useful for Edexcel and also occurs in other A-level boards. Very, very popular kind of exam question. In my previous video, I looked at an example where we had area and we had volume, and I said that the second variant of this question typically is when we have surface area and perimeter. So thought I'd look at this question because this is like the second variant, okay? So this is when we're dealing with perimeter and area. Let's have a look at the question. So it says, figure 3 shows a flower bed. Its shape is a quarter of a circle of radius x with 2 equal rectangles attached along its radii. Each rectangle has a length equal to x meters and a width of y meters. Given that the area of the flower bed is 4 meters squared, show that y is equal to that. Now, again, notice we're following the same pattern as in the previous question. They've given us a piece of information. They've given us the area is 4 meters squared. So just like in the last question, what we're going to do is we're going to write down an expression for the area of the shape, set it equal to 4 meters squared. We're then going to write down an expression for the perimeter. We're going to rearrange one and sub it into the other, and that's going to give us the equation y is equal to 16 minus pi x squared over 8x. Okay, so let's have a look at this then. First of all, let's think about an expression for our area. So what have we got? Well, let's have a little sketch here. Okay, there we go. World's worst sketch. But we've got x and we've got y and we've got x and we've got y. Okay, so this is a quarter of a circle. So this is going to be pi r squared over 4. That's a little rectangle, so it's xy, and that is xy. So our area is going to equal 2 lots of xy plus pi r squared over 4. Okay, so and that we're told is equal to 4. So 4 is equal to 2xy plus pi r squared over 4. So we found our expression now for our area. So now let's turn our attention to the perimeter. Okay, so what have we got? We've got an x there, and we've got an x there. Oh, hang on a minute. I think I've labeled my x and y's in the wrong place there. Let's just put those correct. That is x, and that is y. There we go. Okay, so what have we got for our perimeter? We've got an x and an x, so we've got 2 x's. And we've got a y and a y and a y and a y. Okay, so we've got plus 4 lots of y. And then we've got this little bit here, this arc of this circle, which is a quarter of a circumference. And the circumference of a circle is 2 pi r, or in this case, 2 pi x, because x is like the radius of our circle. And then we've got a quarter of that, so it's divided by 4. Okay, so there's an expression for our perimeter. 2x add 4y add pi x over 2. So that is our expression for our perimeter. Now, what we've got to do now is just like we've done when we've tackled this kind of question previously, we're now going to take this first equation here, we're going to make y the subject, and then we're going to sub it into this equation. Okay, so let's have a look at that. Maybe I'll do that over here. So I'm going to subtract the pi r squared over 4. So I'm going to have 4 minus pi r squared over 4 is equal to 2xy. So all I've done is move that over to there, to the left-hand side. And I'm now going to divide that whole thing by 2x. So I'm going to have 4 minus pi r squared over 4 all over 2x is equal to y. And that goes to 4 over 2x minus pi r squared over 4 times 2x. Because when I break that down, when you're doing a division, when you've got 4r squared over 4 over 2x, that's the same as 4r squared over 4 times by 1 over 2x. Hence, that's why this 2x appears there in that denominator. So that is 4 over 2. That's going to go to 2 over x minus pi r squared over 8x. Okay, and I'm now going to sub that into my equation here. So I'm replacing that is my y equals that. So I'm going to sub that into here now. So I've got 2x plus 4 times 2 over x minus pi r squared over 8x plus pi x over 2. Okay, so our perimeter is now equal to 2x plus 8 over x, because 4 times 2 is 8. And it's going to be minus, now that's 4 and 8, so that's going to go to a half, pi r squared over 2x, like that. And let's see whether we're getting anywhere near what we need to have. Well, we've got our 8 over x, which is super encouraging. That is good. And then let's see what else we've got. So we've got that, and we've also got our plus pi x over 2 there. Okay, now let's have a look at this. Okay, this r that I've got here, that I've been writing as r, is actually x. So that is an x there, that's an x there, that's an x there. So let's just rewrite that as what it is. That is y is equal to 2 over x minus pi x squared over 8x. So that is actually y is equal to 2 over x minus pi x over 8, like that. So yeah, I suddenly wrote it as an r there where that was an x. So having changed that to an x now, that's an x there. That is an x there. So this means that this is now pi x over 2 plus pi x over 2. And then I've got 2x plus 8 over x. Perimeter is equal to that. Now, this minus pi x over 2 and plus pi x over 2 cancel out. And I'm just left with that the perimeter is equal to 2x plus 8 over x, which is what I was trying to prove. Okay, yeah, so just note that I wrote that as an r there when the r is x. So all the way through there, I wrote that as r, but then I realized it's an x, so I changed it to x, and then it all cancels out and we get what we need. So that's part B done, okay? I mean, you know, it is quite a lot of working, you know, for 3 marks when you think about how much algebraic manipulation's gone on there. But nonetheless, that's part B done. Now, part C, and as I've commented before in a previous video, very often this first parts of the question with the rearranging are often quite a lot of rearranging for not very many marks. And usually what happens is the second part of this question is usually worth more marks and is more straightforward. And that's exactly what's going on here. So in the next bit, what we've got going on now is part C, use calculus to find the minimum value of P, and it's worth 5 marks. So it's kind of nice, this question, because there's a break point in it. Even if you get lost in the algebra in the early parts, you can always pick it up here and carry on. So we've got perimeter is equal to 8 over x plus 2x. And we've got to use calculus to find the minimum value of P. So I'm going to rewrite it in a version that's easier for us to differentiate. And we're going to say that dp by dx is going to equal minus 8 over x squared. So we're differentiating, so we're timesing by the power that's there and lowering the power by 1. So minus, and then minus 1 is minus 2. So that's minus 8 over x squared. And then the 2x just goes to 2 when I differentiate that. Now, because we are using a minimum, dp by dx has got to equal 0. So therefore, I've got minus 8 over x squared plus 2 equals 0. So I'm going to take the 8 over x squared across to the other side. So I have 8 over x squared is going to equal 2. Just adding that over there. And then I'm going to times by x squared. So 8 is equal to 2x squared. I'm going to divide by 2. So 4 is equal to x squared. And then I'm going to square root it. So x is equal to plus or minus 2. Now, because in the context of this question, we're dealing with a length, it doesn't make any sense to have a negative length. So we're not going to have minus meters. So we can ignore the negative, and we're going to have x is equal to 2 meters in this case. Perfect. So we've got our value of x. Now we've got to find, use calculus to find the minimum value of perimeter. Well, we know that it occurs now when x is equal to 2 meters. And not only that, earlier on in our workings, we found an expression for y as well. Earlier on in our workings, we found out that y was equal to this. So let's just make a fresh note of that. So we know that y is equal to 2 over x minus pi x over 8. Okay. So from that, we can sub all of this in order to now find out what our perimeter is going to be. So what have we got? Oh, actually, no, we don't even need to do that. We don't even need to do that because we've got our perimeter expression. So it's fine. We can basically just say that our perimeter is equal to 8 over x plus 2x. So our perimeter is equal to 8 over 2 plus 2 times 2. So our perimeter is equal to 4 plus 4, which is equal to 8 meters. Okay. And that, I think, is a really nice 5 marks. I mean, look at, it's relatively straightforward, just some simple differentiation and subbing in. It was far less complicated than part A and part B, and yet it was worth more marks. So I think, and that's the way that these questions tend to go. So look out for that. Just remember that the part, after the rearranging, there's some nice marks to be had. Okay, the last bit of the question, part D, it says, find the width of the rectangle when the perimeter is a minimum. So we've got to find the width of the rectangle when the perimeter is equal to a minimum. Okay, now we've got the expression. Now this is the bit where I was bringing that y equation in. Okay, so we have our y equation is y is equal to, from earlier in the question, 2 over x minus pi x over 8. And we know that the minimum occurs when x is equal to 2. So we can find out what the width of the rectangle, which is y, is when x is equal to 2. So we're going to have y is going to equal 2 over 2 minus pi times by 2 over 8. So we're going to have y is equal to 1 minus pi over 4. Okay, and we could write that as, if we wish, we could think of 1 as 4 over 4 and have it as minus, but this doesn't make any difference. And there's no, you wouldn't lose any marks for whichever way you write this. So we could think of it as that. We could think of it as that. But it says give the answer to the nearest centimeter. So it wants us to put it into our calculators and work that out. And when we do so, we end up that is 21 centimeters to the nearest centimeter. Okay, so that's the second example of differentiation optimization. Look at my previous video if you want an example of a situation where it's volume and area. This one was perimeter and area. Okay, hopefully, I hope that was useful, and I will see you in the next video.